Hi, I'm Leo, this is Crash Course Jenkins, and today we're gonna learn everything we need to know to write any pipeline we want. You really believe that? Of course not. We are going to learn the essentials, but those essentials are going to be sufficient to run pipeline for any development environment and, well, yeah, basically do whatever you want. So, firstly, we are going to run over the Groovy script, syntax and what it can do, what to do with it, how you can basically use it. I'm not pretending to be a developer myself. I'm not going to teach you how to write complex applications in Groovy. There are better men for that. For example, I'm going to link down below the video from Derek Benes. He covers the entire Groovy script in 1 hour. So yeah, if you're interested in more, give it a watch. And now, yeah, let's go run through Groovy script and then through Jenkins classes. That should be enough. Now, all languages start with defining variables. In Groovy, we can define a variable like this. For example, we will put a keyword def, goes for define. A loose var will be equal to a string. It will be a string, and that's it. That's easy. Also, we can specify the type of that variable, so now var is integer. Now, anytime you will use var or trying to assign anything new to it, it can only be an integer. That can save you some troubleshooting headache. Okay, that's done with the variables. Now let's do some logic. Basic if statements. So if a variable is greater or equals to 0, do things. If not, do other things. Simple. Also, with def, we can define a function. Our function takes in 2 arguments, a string and a boolean. So we can say if a boolean is true, return a string, if not, return false. Again, here we define function as a def, so not typed. It can return anything from bananas to strings. In this case, it can return both boolean and a string. Keep that in mind. And naturally, we can call this function and it will just execute as a piece of code written elsewhere. That's what usually the function is for. Now, the string interpolation is fun. It's useful. Usually, when you write a pipeline, you want to output something somewhere, write a log, send a message, email, or whatever. You need to compose a string. In this example, the var will be substituted with the value of the var, and it is 42. As you might recall, like in Bash, you can interpolate variables in a string with or without the curly braces. Curly braces are really handy if you're trying to refer to pieces of an object. More on that later. Also note, string can be specified as a single quote or double quotes. The double quotes do interpolate variables, while single quotes do not. Then arrays, they're called lists here, so lists also defined like everywhere else, like in Python or JavaScript or Java or whatever. In Groovy, a list can be typed or not typed or anything in between. So a boolean, a string and an integer in the same list is totally fine. If you do want to specify a type, same as with variables, instead of def, you're putting in a type. And of course, with lists, we can do a lot of things, like we can add things to the list, we can learn the size of a list. It's useful when you're evaluating stuff. And naturally, call one element from the list by its index in the square brackets. Then a map, that's our basic object. It's a key value pair. Again, not typed, don't care what's there. You can call a single element from a map by its key like this, or with a dot like this. Keep in mind that this key can have any punctuation marks, and if you have those punctuation marks, you must use this square brackets notation. Now for the loops. The simplest for loop iterates I from 0 to 10, and in our case just increments var variable. You can also iterate over a list. So I, in this case, assumes a value of an element of the list. There's another way to iterate over lists. The bigger list, for example, we can call the method each, and there is an internal iterator, the variable named it, which will again assume the value of the set element. If you don't like the word it, you can specify the key and value variable, so they will assume the values of key and value of value. Yeah. And now to more complex stuff. This, for example, is a handy short piece of code to send a GET request. So right here we're just calling google.com and getting the response code. If it's okay, we print out the text from this response. But it's not going to be okay always, so we want to catch that. That's why we have try-catch block. We want our out variable to assume the value of this text response. And if something goes wrong, we can throw an exception, and that's basically will stop our pipeline from executing. Then we'll just fail, it will be red in our Jenkins UI. So the basic Groovy is out of the way, let's head to the interesting stuff, the Jenkins classes. First of all, beginning every pipeline, it's usually a good idea to have the parameters for your job. Much like we did in the Jenkins UI, in the web UI, we can specify all those properties like parameters, triggers, GitHub projects, whatever there is, in the Jenkins file. It's handy because you don't really have to ever go to the UI. You can do all the things from the Git repository or from your text editor. Now, any pipeline must have a node allocated to it. Anything outside this node directive can run just basic Groovy. So defining variables, importing classes, defining function, that sort of things. But the actual work, like the shell scripts, the build commands, can only be run inside the node directive. This one just assigns a random executor that doesn't have any labels or accepts jobs that do not have any labels. You might remember that we always specified a node because all our executors, all our Docker images that actually ran things, had labels and forced us to use those labels, otherwise it just has no idea where to run the thing. And we call a specific node like this. We just enter a label here. So like this, our pipeline will run on a node labeled KTS all-in-one. In case of Kubernetes, we must specify exactly which container to use. Otherwise, it will run everything in the default GNLP container, whose only job is to communicate with Jenkins and push logs back and forth. And we can't actually do any useful work there. It's always a good idea to organize pipelines into stages. That way, we will know exactly where it fails, and also if you are using fancy UIs, like for example here, it tells us exactly which stage took what time or where it failed. Or if you want even fancier pictures, there is a Blue Ocean plugin. It's a beautiful UI. Rarely useful, but here you can just pick a stage and view logs only from that stage. The first thing every modern pipeline actually does is checks out the Git repository with the code. Well, you usually want to build the code, right? It can easily be done with this Git class in Jenkins. It only requires a branch, a URL of the repository, and credentials ID if you have a private repository. If you want a bit more advanced behavior, you can use the checkout class. It allows you to do all the things, like for example, this git command does not allow you to specify like what subdirectory you want your repository to be cloned in. Here, it's done like this. And yeah, I know there's a lot of words, it's frustrating and puts off a lot of people trying to write pipelines, but there is actually an easy way to get all those nonsense words from the Jenkins UI. I'll show you that now. You can open configuration of any pipeline, and right in the end there is a link, pipeline syntax. It gets you to a page with the snippet generator where you can take any class, any plugin, any command there is in Jenkins and populate it from it. For example, I want to check out this repository, this one, into a subdirectory. Here we can actually tell it to check out into a subdirectory, subdir, and just click generate snippet and it will give us all those nonsense words and things and stuff. Rather handy. Unfortunately, it does give you one-liner, but anyway, It's better than trying to remember all those parameters by heart. Now that we have checked out our repository, we can actually do some stuff with it now. Let's run some shell script. Shell scripts are run with this sh thing. It takes argument script and it just spawns a shell and runs the command here in a workspace directory. There's not really much to it. You can, if you want to, return standard output from your script into a variable. So this variable will assume the value of this stdout. So everything the npm run test commands dumps into the shell, into the terminal, will be stored in this variable. Yeah, and also remember that each instance of sh command spawns a new shell. So if you were to define a bash variable like in simple shell variable boo equals var, it will only live within this execution of a shell. In this one it will not be available because it's a new instance of a shell. Now to the next stage, to return status. We can actually return the status of a shell command like this npm run build can return status. So if the npm run build exits with 0, the status will become 0. If not, it will become, well, 128 or how the npm fails, I don't remember. Also, please note, this or this will fail your build. The stage test will be failed, therefore the build will fail if the npm command or any command you write in there would fail. That parameter allows us to pass the build on no matter the result. It will just put the status code right here, and later we can handle this error however you want. Now let's say you actually have used multiple repositories with multiple directories and you want to change the context of your build. Let's change it. So with the dir directive we can change the subdirectory in which we work. So all the shells, all the file handlers, everything will be spawned in the context of this subdirectory. Now, if you would like to use some credentials to log in somewhere, write a password in std, well, I'm not here to judge, but here's how you can do it securely. There is an option with credentials. You give it credentials ID from your credentials store and names of variables for your username and password, or private key, public key, certificates, anything you can think of. And right here, you can use it just as variables, and it will mask those variables, the occurrence of those variables in logs, which is secure. So even if you open your logs for everyone, they will not see your usernames and passwords. And much like that, you can also specify environment variables for all the shells spawned within this block. So within foo equals bar, we can add some more, and those variables will be in the environment, so the shells that are spawned there will have them available. Now, occasionally you will want to read some files from your hard disk. This is the easiest way to do so. This readFile class allows you to read a file as a text into a file variable. Do whatever you want with it later. And last but not least, we can build other jobs. So with this directive, we can tell this job to spawn build of another job. Just give it the job name, parameters, and here you go, it will spawn it and wait for its completion. And to conclude all this, there is a parallel class that allows you to, well, do things in parallel. We are creating two branches that just builds one job, builds another job, and there is quite a bit of options to like fail fast, true, so if any of them fails, the entire thing fails and will not wait for the completions of the rest. And that is everything you need to know to write pipeline for any development environment. I myself use only those tools. Rarely something else is required, like complex cycles, external classes, I don't know. And that concludes our crash course on Jenkins. All of this does not imply that there is nothing more about Jenkins to learn or discover. Of course there is, and we will in later videos. But for now, this is all you need. I've been Leo, this was DevOps Pod. Bye bye!